All right, so here it's saying, if you want to avoid sampling bias, what are some things you could do? Well, I know what you're thinking. You're thinking, well, I could have Alana not pull my scoop for me. Yes, that's true. But I promise I wasn't being very biased in how I did it. But when we do it in class, a lot of students mention they could close your eyes or blindfold yourself when taking the scoop. Our eyes are drawn to red, and so we might get more red in a scoop than we mean to, right? So that would be one way to avoid bias in your sample. Let's see. There's one other thing I want to mention, but I think it'll fit better into the other question. But I mean, there are a lot of things you could do. Make sure that you take a fair size scoop, make sure that, that all scoops are around the same size and such. I'll just leave it ... I mean, there's all sorts of stuff you could do. All right, but the thing in class is it's one box, and so as people here, let me show you. Whoopsie. No. Oh, nope, there it is. So what happens is that one person scoops, and then another person scoops, and another person scoops, and they all take it back to their desk and they count. But that means that by the time you get to the bottom of the box, you have less and less freedom, as it were. In other words, you're losing to some extent a little bit of the independency. Since everybody's removing their beads all at once, technically, this is not independent because the beads were not replaced. Could this affect the outcome? It definitely could affect the outcome. If I could spell the word definitely. Ugh, it's too late at night. Definitely could affect the outcome if earlier people draw more reds out or something like that. And remember, this is really a metaphor for something else. I mean, let me just say, so like on election day, for example, pretend this is, I don't know, all the people are going to vote in the whole of America. Okay, so the first scoop that comes out is like Maine, and the last scoop that comes out is Hawaii. Get it? Because they work east to west, like time zones. So by the time, the other 49 states have gone, Hawaii's like, well, shoot, I don't even need to pull out because everybody knows who's going to win the election by now because I can tell what's going to happen, right? So having those first 49 scoops go kind of affects what's left for the 50th one. I mean, it might not affect the actual voting percentage in Hawaii, but it makes the people in Hawaii feel like that doesn't matter if they pull their scoop out or not. Does that make sense? So you're losing a little bit of something. I mean, also what happens, and there's always a big concern about this, is in elections, if everybody knows that, well, for example, in the Obama-McCain example, Obama was winning in all the East Coast states, for example. And then, he lost in the Midwest. So does that affect California? Do California people not as likely to vote for him because they know he's not going to win or know he is going to win or whatever? And so they don't even bother going to vote. Right? It has a big effect because it's not independent anymore if you see what's happening in the other states, and that affects how you choose to vote in your state. This is always a big problem with elections. Okay, so the sampling distribution of p hat, how does this work? So if you're going to look at one person's scoop and the next person's scoop and the next person's scoop, what has to happen? You have to make it sure that each scoop, each sample size is less than 5% of the population size. Otherwise, it's not independent, and we have to have independence. You have to make sure that n times p times 1 minus p is greater than 10. This part right here is what ensures that it's going to be normally distributed. The mean is going to be p, and the standard deviation is that ugly formula right there. Now, those formulas should look familiar to you because they're the same ones we saw in binomial distribution 6.2. Right? These formulas came right out of that section. All right, I'll see you here next time.